Hello everyone, here in this video we are solving a problem basing on surface tension. Let me first try to understand what the problem is. Let me read out. When a wire of length which having much bigger than the radius of that wire, that means the length of the wire is much dominating the thickness of the wire. It means to say it's a thin wire. Having a cross-sectional radius r is floating on the surface of a liquid of surface tension T. Let me stop here for a moment and try to visualize what does it mean, right? So there is a liquid surface like this in a vessel, in a container. Because of the surface tension, the liquid acquire a particular shape, a concave shape. On this, we are keeping a wire. This is that wire. This wire is having a length L, having a radius R. It is floating. So let me identify what are the forces acting on this wire. See, wire will have definitely certain weight. That weight acts in the downward direction. Surface tension acts. A component of the surface tension force acts in upward direction. Force, not complete force, a part of the surface tension force. So when these two forces are being balanced, then the wire will float. So when he says it is floating on the surface of the liquid, the basic condition is the force acting downward due to the gravitational force is equal to force upward due to the surface tension force. That's a basic condition that you want. In that case, he is asking to find out what is the maximum radius of that wire so that this wire won't sink. So as we understand the problem now, we try to solve this problem. We shall first of all find out what is the force acting in the downward direction. That is the weight of that wire. That is mass of the wire into acceleration due to gravity. Mass of the wire can be written like volume of the wire into density of the wire into acceleration due to gravity. Assume that d is a term that is given in the equation. Volume of a wire can be written like area into length. Area of the wire is pi r square, length is L and dc. This is the total force acting in the downward direction. Then there must be some force who is acting in the upward direction due to the surface tension, which can be found basing on the surface tension definition. What's the definition of the surface tension is, as we know, it's a force acting per unit length, which is tangential to the surface, and that's all is there as we have defined. Here, the wire is the wire, this wire, that what are we talking about? This wire is thin such that its inner surface, that is this inner surface as well as this outer surface, both are in contact with the surface of the liquid. So in the place of the length, I shall write 2L. Both the parts of the uh, wire are in contact with the surface of the liquid. So what is the force acting in the upward direction is surface tension into 2L. Now I know force upward, I know force downward, I know the equation, the condition for the problem for the wire to float. So let me just substitute both of them in the equation. That is force downward is equal to force upward. So when you simplify, force downward is this much pi r square L dg, where d is the density of the wire. Force upward is T into 2L, where T is the surface tension. Then one L can be cancelled. You want R, so R square can be written as 2 into T by pi dg. So the radius of the wire maximum is root of 2 into tension by pi dg, where d is the density, T is the surface tension. I want you to observe and understand one point carefully. There is no term L here. That means what? Max radius of wire is independent of length. It doesn't make a difference what the length of the wire is. But of course, it depends on the density of the wire, of course, acceleration due to gravity constant, surface tension of the liquid. It's not dependent on the length of the wire. Suppose I just want to extend a little further. Suppose somebody want you to measure what is the diameter of that wire. If that is the question, so maximum diameter of the wire is. Diameter of the wire is twice the radius. That is twice into radius we have already calculated here. 2 into surface tension by pi dg. Of course, you can take this 2 into the square root, that becomes 4. So that's square root of 4 into 2t by pi dg. So that can be written like root of 8 into surface tension by pi dc. So the core concept of solving this problem is that there is a surface tension force acting on the floating body in upward direction, gravitational force acting in the downward direction. When the mass is, say, small, the upward force is able to balance it. But if the weight increases, the downward force becomes large such that the bodies will sink. That's why we can't float on the surface of the liquid. Rather, small insects do able to do it, right? Thank you. We'll see you again.